Hello. Hi. Hi, everyone. Hi, Jay Focused. Hi, Stockholm. It's very happy. I'm very happy to see all of you here. And we're gonna talk about contract tests, microservices, Spring frameworks, and test containers and tests. I hope you got a lovely morning with the keynote and you were all inspired on various topics from productivity with Java and the upcoming AI revolution cycle, but for a few years maybe we still need to do our jobs manually, and I think it would be interesting to see how we can do it maybe better or learn some tools, even if you don't need to apply them immediately to solve a particular problem that you're having. It might be just nice to know the approaches and leverage this information later. So imagine you come back from the conference, you go back at your work, and you are, I assume, mostly developers, right? And you are very tingly with all the information and cool stuff that we learned here at the conference, and you start building stuff, and it's Friday, and then you deploy it, right? And you push it, and it gets deployed, and then everything breaks, of course, because that's how software development goes, right? You create stuff, and then it doesn't work. Sometimes it works, but also sometimes it doesn't, which is incidentally one of the big dangers of AI that I see right now, but that's a separate topic. So you broke it, you're responsible, you need to fix it. But more importantly than just fixing it, you need to establish the processes and figure out your software development in a way that will prevent the incidents like that happening again. So you need like a safer way to change software. And of course, how do we do that? We do that with tests. How many of you write tests? Very good. How many of you trust your tests when they are broken? When the build is red, you know that the application is broken. Way less. So like people write tests, but when they're broken, you don't believe the application is broken. That's an interesting signal. And now the next level of test usefulness. How many of you believe your tests when the build is green? So green means it's good to go to production because everything is all right. 4 people, 4.5, and someone like, that's not faith, that's like sometimes belief, sort of. Right, so ideally, of course, the tests would be our very good confidence signal for the quality of our application. And it also happens that not all tests are equal for this. And then if you cover your application mostly with unit tests that test chunks of things, small pieces of code in isolation, they are very convenient to write and work with, but they might not be very confidence-inspiring at a larger scale. And then sort of the higher level you go into integration tests or high-level functional tests or contract tests that we're going to talk about here, then the more confidence you can achieve, which is good. So we're going to talk about tests, and this is how I came on this stage. My name is Oleg Šelajev, and I work at Docker currently, and I work on Testcontainers, which is the open source libraries for container manipulation things for pre-production use cases. And I'm a developer relations person, so you can ask me about anything. And chances are I wouldn't know the answer, but I would know people who know the answer. And I'm very good at networking. And if you want to find me online later to ask any questions, I almost universally go by @Šelajev at various networks. My favorite one currently to give to people is my YouTube, where I go to conferences way more often than normal developers, usually. And then I record short videos with people there asking them questions about technology. So I feel it's very cool. It also could be sufficiently lame, but you can check it out. And you also you have the username there if you want to just follow me elsewhere. Right, so let's talk about this. Our systems normally consist of multiple services, and they talk with each other, and that communication patterns could be different, but then essentially they just all pass messages to each other. The message format could be different. It could be HTTP queries, or it could be like an actual, like a like a message broker message, or it could be encoded as a particular format. But in a nutshell, systems send messages to each other and then get responses, and then it sometimes works and sometimes it doesn't. We're gonna work with a sample application today here. It's gonna be a system of 2 services. They implement like a coffee serving application. There is one waiter application that will take the orders in and request the implementation of those orders from a barista service. And they're gonna talk via Apache Kafka. Because even though any sort of communication system between messages could be used as an example, having an asynchronous communication via message queue is, we're going to use Kafka as a message queue, right? But through a message broker, it's a little bit more interesting, and it gives you a slightly more advanced example that you can more readily adapt to your needs, should you need that, or if you need to adapt this to a synchronous communication over just HTTP, it's much easier to go into the simpler direction than seeing an example of a simpler thing and then having to implement or figure out a more complex solution. So we have 2 microservices. Both of them are going to use Spring Boot. How many of you use Spring? Very good. I expected that very much. So we're going to look at that. So how do we ensure that when those services communicate, they actually work together and they sort of speak the same language, that there are no mistakes in this communication? And how do we ensure that when we evolve those services independently, that they still keep this property of being able to speak the same language, right? So one backend can accept the valid messages from the consumer, and the consumer will get, and then it will produce the valid outputs as a producer. How do you do that? The most normal answer, of course, is communication, right? If you are responsible for the both parties, or other people are responsible, you just go and talk to them, right? And you agree on things, and then you follow your agreement. And that would be great, because everything would just work. But we also know that it never happens, because we are all human, and communicating with humans is hard. So that doesn't work out in practice, especially in larger teams, especially if you are further away, separated from your, say, producer. Or by the way, how many of you work mostly on like sort of producer type applications, which produce stuff like used as an API? Right. So how many of you work on the consumer side of applications where you use other third-party services? Okay, equally, half and half. Very good. Both of them could benefit from contract tests. And the contract test is literally mostly the tool for organizing communication between different teams and formalizing that in the form of tests. So there is a rigorous process in your build that can tell you whether you implement the protocol of communicating correctly or not. And so it's all to prevent incidents in production. And those are the tests, right? So you want to use them as a signal for your quality of your software that you're developing currently. There could be very different errors in this communication, starting from simple misconfiguration of basic stuff, like for example topic names in producers and consumers could be spelled differently for just bare typos or any sort of cultural differences, where some words are spelled differently based on whether you were in Britain or US, or God forbid accidentally your first language is a different language and you just don't know. So it could be that your fields are called differently. It could be that your data is actually incorrect, or it could be that, for example, additional information that you put in the messages is just doesn't conform on the producer and the consumer end. And all of those will make the communication break at certain points, and then you have to encode this. The most notable example of that is, of course, the HTTP referrer field, which is for 30 years now sits with a typo, and I don't think that typo is going away anywhere. because the whole world expects it to have a typo there, and we are not going to touch it because it works. But we could also maybe improve that for future generations eventually. So how do you do this? You want to write tests, and you want to write tests where you sort of simulate the other party in the communication, right? And then you actually run your application through this simulated communication, and you verify that the responses that the other party produces are what you expect. The problem with that is, of course, when you write both parties yourself within the same project, you will definitely make the same mistakes because you are re-implementing your own assumptions in your head. So you won't catch any of the errors that come from you not having the correct assumptions of what the protocol is, whether what is the schema of your message, which you can have with schema validation things, but also what are the correct responses to particular messages, what are the format of the data within, and so on. If you are implementing both sides, this is slightly less efficient than if both parties are a part of this interaction. So the solution is that you cannot just stop everything, mock those third-party services by yourself, and call it a day, because you will break it. So the solution for that is, one of the solutions is the contracts, and we're gonna talk about this, and we're gonna talk about the Spring Boot implementation of this with Spring Cloud contracts, and a large part of that is because the co-author of this talk, Olga from the Spring Cloud contract team, she was supposed to be here but couldn't come, so you will suffer through me alone here on the stage. And she, of course, is very close to Spring Cloud contract, and that was the solution that we finalized for the session. There are other implementations of contract tests that are available, sort of approaches and frameworks that you can try, and more or less they operate on a similar set of abstractions and moving parts. So this would be enough to give you the introduction to this. So how does Spring Cloud consumer-driven contracts work? You don't get the free stubs or free mocks of your services to implement your tests with by itself, right? You need to provide an input, and you need to formalize what the communication looks like. There are necessary components to writing contract tests with Spring Cloud Contract, and it starts with the build tool plugin, right? Something needs to generate you some tests, and well, generate not as in a generative AI sense of word, not imagine the tests, but take your inputs formalized in a way and actually produce the test cases for JUnit or other testing library that you're gonna run. And it cannot be in your application lifecycle because there is no reason for it to be in your actual application lifecycle. It's a part of your build process. So the best is to integrate this with the build tool. And so it integrates, Spring Cloud Contract integrates as a build tool plugin. You, of course, need to provide the contracts definitions, which are, well, text files that tell what is the communication looks like. When you ask a particular message, we send a particular message there. You need a certain response, or you will accept certain messages on certain configured topics, and so on. What do errors look like? How do errors propagate to the system, and so on. Contract definitions, we need them. And we also need to provide a test setup configuration, because we want to run tests in the conditions and the setups that are realistic enough. So if we're talking about 2 microservices that communicate via Kafka, we would like our test to actually work with a real instance of Kafka, because then our application can send stuff to it, and our contract test or whatever tests are generated based on the contract's definitions can actually work also with the message broker and verify that the communication actually happens. So we would like to have realistic conditions, and for that we need to provide the actual details how to set up the environment for all our applications to work with. And that will generate the tests. And here's how it looks like in my IDE. Don't look at this other one. This is an artifact. I don't know why it's there. Right, so we have two very simple projects. They're both Spring Boot applications. They're available online. You can clone them on GitHub if you want. There will be a link later. And one of them is a Barista application. It's a normal Spring Boot application, and it's very, very simple, right? So it gives us mostly, right? Well, it's a Spring application, right? A Barista application, and it declares some beans for working with topics in Kafka, and there are different ones, and you can have your configuration. And the only logic in the sample application here is the handler for the messages, which will process the orders that are received on the orders topic, log them, and then, well, we simulate processing and preparing coffee, and then we, via coffee service, we can just return whatever the data that Barista returns currently. The actual business logic of this is not, strictly speaking, important, right? It's just the important parts are that it is requested from our handler, and then our handler sends the messages back into the topics. And then if we cannot produce the coffee, we're going to send the errors. So this is our Barista application. It's very, very simple. And we have a waiter application, which also works in a very similar way. The waiter application has the actual HTTP endpoint on which it requests the orders, right? And when you send stuff into it, then it will process it and send the orders to our backend producer to produce our coffee. And then it will, on the other side, it will also receive the servings and then work with that. Right? So they two need to work in tandem. We're going to start with our Barista application, and we're going to start with the tests for this. Right? We started, what was the first thing that we needed? We need the build plugin, and the build plugin is very simple. You add it, it's a Spring Boot Cloud Contract Maven plugin that you put in, and the important thing is you are completely free in choosing what testing libraries you are using. Right? So you can configure whether you want tests to be JUnit tests, and you need to provide the base class name. And this base class name serves as that test setup configuration provider. All our use cases or our tests for this contract tests, they will be generated by this Maven plugin. And of course, there is a Gradle version of that as well, if you want that. And they will all extend from this base test class, which will serve as our environment. So in this base test class, what we do, we create the actual instance of Kafka. Shout out to Confluent for providing Docker images for Kafka. And we're going to set it up using Testcontainers, which are the libraries for running things in containers. We're going to use the service connection annotation from Spring Boot, which works. It's an integration with Testcontainers, and it will allow our Spring Boot to use whatever Testcontainers container is annotated with that as its main data source for that type. If you put service connection on a, how many of you know about Testcontainers? Okay, most of you. So I don't need a very in detail demo of this. But in short, Testcontainers is an abstraction that allows you programmatically create and work with containers for pre-production use cases. And it comes with an ecosystem of modules, so I don't need to write particular code to work with, like whether I want to run my Postgres, my database, my Mongo, my Kafka. I can just use abstractions and create those and work with them as if they were Java objects. Very convenient. So now Spring Boot has the service connection thing, and then you put it on the test container, and then if it's a database, Spring will take it as the main data source. If it's Kafka, it will configure it to use as the main Kafka. So it's very, very nice to use in tests or for your local development setup, because you don't need to actually know any of the underlying details unless you want to change them. Right? So in our base test class, what do? As in every good test, we need three parts, right? We need to set up the conditions, we need to execute the program on the test, and then we verify the behaviors and our assumptions. So we set up the conditions by providing the entry points for our contract test to create the data that we're going to work with. So we can say that, okay, we want to trigger serving of a latte, and we want to trigger an error by ordering something with a typo in it. So those will be our entry points into the tests. And we also provide the sort of the plumbing, which is important and looks a little bit scary, but you don't have to worry about this. It will instruct the contract test. It will instruct the test how to actually go and read the messages from our Kafka, right? Because we create the base setup on the fly dynamically. So by default, the test cannot know how to particularly get the messages on the other side, right? It knows how to verify that the messages conform to a contract that we have, or we will specify. We didn't look at it yet, but it can do the actual testing part of that, but it doesn't have out-of-the-box plumbing to get those messages. This will be much simpler in a synchronous HTTP world, because you will not need to specify how to get messages. They will go to you automatically. But if you work with the sort of through Kafka, asynchronous message passing, then you would need to have something like this. But it's also, this is a very default sort of boilerplate code, because when you already know how you're going to create an instance of Kafka, that is pretty much just the abstraction over this, right? And you know that you're working with a Spring application, there is only so many ways to read messages out of a Kafka topic from within the Spring application. So the good thing here is that there is this repository, absolutely amazing repository called Spring Cloud Contract Samples. And then it provides you with the details and examples how to create that plumbing code for almost all possible use cases that you can think of. So you don't need to write this code yourself. It's fairly standard boilerplate. You just need to specify maybe some configuration parameters where to listen for messages, but the bulk of this is abstracted away. And it might get into the Spring Cloud contract as a library, but it's not at that point of being standardized and popular yet. So you have to go and copy paste a little bit of code or ask your favorite AI assistant to do that automatically for you if you trust their outputs. Right, so this is our base test class, and then we have our build tool plugin configured, and the third thing is what we need. We need the actual contracts, right? Wait a second, where were we? Right, do we need the contracts? Tests, resources, contracts, right? The contracts for Spring Cloud Contract could be defined in different ways. It can be a GUI file like here, if you are into dynamic languages like that. I think it can be a Kotlin definition. It could be JSON, and I think XML as well. So there are a number of ways how you can define the contract. You pick something that would work for you. More importantly, you pick something that would work for your counterpart as well. This is not, it's a relationship, right? If you have two services, producer and consumer, both should agree on the common infrastructure, which is equally relatable advice for relationships in life, not just with other developers, right? But you pick something and then you describe what the contracts look like. There are a few important parts. You label your interactions and you give them names. You say what are those going to be triggered by, and this is a reference to the code that we wrote in the base class. And then you verify that when we serve the serving, we want to get the message, and we want to output a message to the servings with bodies like this. You can note that there are interesting also semantical placeholders for things that are not strictly deterministic, but can be anything of a particular type, right? So you have placeholders that can generate random UIDs for you, random IDs or random strings or other types like dates or times if you want, right? So they're not a single hard-coded value, but when you verify that the output came to you and there is a UID in that, right? You cannot match to a particular one because, well, the more servings you request from a barista, a unique ID will probably be different. So we have those placeholders to cover sets of values at once, or like dates, right? If you need to receive a date back, you cannot just hardcore a value because later you're going to run the test again and the date is going to be different. So you can record the messages and you record the headers and you record all the data. And the same way, you also can provide the contracts for the error conditions, which is when we trigger the error from the code, that's the output. So we are doing this on the producer side currently, right? And the contracts here in this example reside in the producer, on the producer side, which gives the producer quite a bit more power, because if I, as a consumer, want to negotiate on those contracts and work with them, I kind of sort of need to come to this repository and request permissions and maybe send pull requests, and then you as a producer kind of sort of are very much at home working with this. But this is the detail. The contracts can reside in any of the particular repositories or a separate repository with, I don't know, even if you want to have additional process on top of that, how teams negotiate. But the important part is they are a part of your code, and that means that there are established ways to work with them as text files within your teams, because that is what you do daily, right? It's much, much better than having some information in a wiki somewhere or in a Google Doc that describes the communication patterns, because then they will get stale. Right, so we have those three things now, right? We have the build plugin, we have the contracts defined, and we have our base application. So we can run our situation here. Can we run the situation? I think we can. We can try it. Okay, so we in the barista, and we're gonna run this Maven clean install. What will happen now is that the build tool will look at our contract, look at the configuration, look at our contracts, look at our base class, and it will generate tests for us, right? So here, there are no tests, right? We don't have any tests in this project, which I don't advocate for personally, but it's an example, right? And the tests do run. So those tests were created automatically from our parts, and they were put here in our generated test sources folder for the contract tests, and it created the contract test verifier, which is exactly what you would expect, right? It validates that when we trigger errors, the contract is correct, and we verify our small little message field. And also when we trigger serving, that we've also verified that the headers are there and the headers of the correct type, and the data also matches the correct things that we expected from the contract. Your contract can be of various complexity, or you can encode various interactions, but this is the basic of it. You don't need to actually verify all the particular tests, and our application, when we built, actually run the tests, spin up our barista application, spin up our Kafka example, right? So here we're gonna see it run Kafka with our test containers. Give me the logs. It ran Kafka. It connected to our Docker environment, and then it run the actual tests, and it sent messages into Kafka, right? And then it verified that the messages appeared there in our Kafka. So this is a very now I can be fairly confident that if I deploy this application, and if there is some configuration where Kafka is located, then my application can actually produce those things. It's a producer. Interestingly enough, this is the producer that isn't triggered from the outside. We just internally say, like, go create a coffee, and then from the code itself, and we verify one part of it, right? So that the producer produces correct messages. Now, now we need to go back to the slides and do a little bit of repeat, right? So we had the generated tests, and those tests, besides verifying the correctness, also generated us the stubs. The stubs. Right. A little run by what we did. We looked at the build. We looked at the producer test setup, created the environment, created the inputs, produced the output by poking into production code. We had these contract samples we took the code to read messages from Kafka. We used test containers to create the Kafka container, spin it with the module. We provided contract definitions that looks a little bit like this and can be of any complexity. We generated the tests and we run the tests, right? And then from those tests, the most important part of this whole thing, actually, why did we do this, right? Why did we go through this more formal process of creating those tests when I could have done that manually by myself, right? It's not that hard to trigger my application and verify a message in the broker. Why did I go through all this hassle? Is to get the stubs that are automatically generated for me. We looked at the tests. Come on, ID. We look at the tests and we generated the stubs, right? Those guys. Why is it important? Because when we did this installation thing, right? What it didn't only install our application, Barista application, to our local Maven repository, it also created the jar for the stubs and also installed it in our repository. So now that jar contains classes that we can use on the other side of our interaction tests. And those stubs are generated based on our producer, and they implement the behaviors that we just verified the producer actually has. So when I will use those stubs on the consumer side for my integration tests, and then we'll verify that that interaction with the stub works as expected, I can be sure that my consumer and my producer are speaking the same language because we just verified that with an automatic process. So this is actually what we wanted to get from this automatic approach. We wanted the automatic verified mock that we can trust that it is correct in modeling our producer side. So, and with that, we get to the consumer side, like to this particular slide. There are slight discussions whether very often people ask questions whether are contracts just nothing more than a schema validation, right? Like we can validate schema without all this complex procedure, and it's not exactly schema. It's a much more flexible approach. You can verify individual parts of your interactions to the extent your application actually needs it. If I'm a consumer and I'm working with the third-party API and I don't need the whole area of its API, but I'm only talking to one or two endpoints in a way, then I don't care whether that producer implements actually more of the schema, but I only care of the parts that I'm interested in. And that allows me to evolve the system of two parties in a more flexible way. Because with a rigid schema, I can never tell who is using which parts of my application, right? Because as soon as the schema is broken, right, my test will be broken, and that's going to be it. And with the contract tests, I can evolve my producer in a predictable way and know that as long as everyone runs tests in the same way, I know that I can evolve my schema correctly without breaking the users. It's much, much easier to do when you control actually both ends. If you are something like GitHub, then however much stubs or mocks you publish, there will be people who are using and not upgrading like a API version from ages ago. But I assume more or less we're working in the enterprise situations where there is some incentive to evolve both parts of the communication. So we did the waiter, we got the stubs. How do we use those stubs? Let's go to our waiter application. Our waiter application it doesn't now Now, we don't need to have those more complex parts of the test setup, because all the complexity was handled currently on the producer side. We automatically generated stubs. So on the consumer side, what we can just have decent, normal, solid integration tests that will simulate the producer by using those stubs. And if that will work, that will work. How do we do that? We do that as we do integration tests everywhere else. So in the Spring Boot world, we're going to have the Spring Boot test that will create our application fully. We're going to configure the stub runner. We will configure our service mocks to use our stubs that were generated in the previous steps. We are going to use the local mode, so the test will go to my local Maven repository, but it of course can go to any, like your in-house Artifactory or any Maven repository that you wish to configure. And then we auto-wire the stub triggers. Oops, sorry. Right? And our tests on the consumer side will look absolutely normal as any normal integration test. So we're going to spin up this waiter application. We're going to touch the orders endpoint to order some coffees. We're going to use, in this particular example, rest assured to do the HTTP queries. You can use whichever framework you prefer. Rest assured is very, very good. So if you're not using that, you can take a look. It is a good tool to have. So we're gonna trigger the order. Essentially, what will happen? It should send the Kafka messages to our barista application. Then we're gonna trigger the serving, right? And this is the interaction from the contract. We're gonna say that stubs, we are gonna trigger the serving now, like do the serving, and it will provide us with a coffee for the specification, and then we're gonna just wait on our waiter application to receive the messages from our Apache Kafka, and then assert on the logic. This serving application is that simple. So what it does, it does nothing, right? It just processes. Where was it? It just processes the serving messages and logs them to console, right? So it listens to the servings and logs them. So in our tests, we verify exactly that. We just await to a certain point. We don't verify that we actually read the message, right? We just verify the outcomes of that. So we verify the logs, and the same we're gonna process with the end, right? We set up the integration test the same way we set up all integration tests, and then we do need the instance of Kafka for this, right? Because our consumer and producer talked through that, and we're gonna use the test containers for that. And because this is a integration test, we're gonna mark our Kafka container as a bean. So Spring Boot will handle the lifecycle of that automatically for that. We're gonna mark it with a service connection. So the details of the connection, you don't need to worry about bootstrap servers or anything like that. And we just slap this test configuration on our tests, and they're gonna run. And I think we can run this, and it will work. So it's gonna work in just a second. Everything is super fast here, right? I'm currently using the local Docker desktop for my Docker ID for my Docker environment. Of course, you can use some things like Testcontainers Cloud if you don't want to run Docker locally, and it would work equally as good. So this is how we create tests, and they look like normal integration tests, right? The only part that we receive from this contract tests process that we established is those stubs that were automatically generated for triggering our message sending, right? And of course, the benefits of that is that it encodes the process. So now you will have to talk to other people, because if you want to evolve the behavior of your producer, there are tests that will tell you that you cannot just break things on a whim, right? You need to update the contract and then there has to be a little dance between two projects. There is a slide for this, how to evolve this, right? The important parts here. Oh, I wanted to show you a thing. So with the same setup, actually, why do I like those integration tests so much? Is because with the same setup of having containers in the configuration, I can also work with the same setup locally when I develop my application. So I can have my test application here. I can have my test application that will just sit on my test class path and use the same containers configuration for this. And then I would just run it. I can run it and my application will spin up. Normally it will spin up my containers, and I can work with it locally by myself without having to provide any additional environment setup, right? I do need this dynamic environments for my tests, and I'm gonna reuse them very naturally for my local development. So if I go here, where's my order controller? If I just go to my order template, right? Here, okay, I have an espresso here already. So if I run this one, we can see that our order went through. There was a 201, created responses back, and something happened. And I can see that my Kafka, CP Kafka container is running there. I'm using the Testcontainers desktop application to work with my Testcontainers containers a little bit easier. For example, I can go into my container, right, and just look what's in there if I want to. Right. Oh, right. I have a minute because I have just a little bit more slides. I'm going to show you a thing. How many of you have seen Docker debug? It's very recently released into the wild. It's a feature of the Docker desktop thing where you can debug containers in a very cool way. So if I'm here in the container, right, there is not a lot of what I can do. There are no tools. It's a production container, right? There is no tools installed. There is like if I do VI, there is no VI. If I do things, so what Docker debug does, right? What I can do, if I have my containers, I can say Docker debug. I hope this works. And then it would do this super cool thing where it will pull in like a Nick sauce based container and overlay it with the container that you want to debug. And this higher level container, the debug container, comes with tools, right? But I also see all my actually like the target container file system and processes and everything, but I can just bring tools from outside. So here I have Vi, for example, right? This works, right? So if you work with containers, this is actually a cool thing that you can maybe look and try if you find yourself debugging containers. It's very cool. There are more features that you can do, but I just wanted to give a little highlight. I think it was released just a week ago or 2 weeks ago. So I think it's very cool. I didn't plan on talking about it before, but then yesterday I was like, this is so cool, because I was trying to debug something. Right, so we looked at the consumer tests. We look at how you can use the same environment and the same setup that you use for your integration tests to create local development environments, right? Because then it gives you this clone and run experience for the projects, because you know that your projects will have to have tests. You know that they will have to have integration tests, if for no other reason than to have contract definitions verified automatically, and that gives you the local environment that you don't have to think about, right? You could just clone the project, click run, or run the Maven or Gradle tasks for that, and out of the box, it's going to run with actual real things that you're going to use in production, like Apache Kafka. You can use Testcontainers desktop. It comes with the really good some developer tooling that is targeting Testcontainers-based setup specifically, like for example that services abstraction where I went into terminal for Kafka. My Apache Kafka container with Testcontainers can come and go because I've run tests. They come, they go again. They give you repeatable ephemeral environments, but the Testcontainers desktop it's a free application, right? It's written there. That's free application, knows about that, and you can work with it a little bit more efficiently. Right, so we have 5 minutes. Let's talk about some strategies, right? You can have the contracts with the producer, right? And then like all the different setups gives you different trade-offs of how well thought through the communication is for different parties. The providers are, the contracts are with providers, right? The providers have more control over them. They don't need to know how the API are used. They're just there. And then the evolution process on the consumer side is a little bit harder. If the contracts are with the consumer, right, there is the opposite problem is because if you have multiple consumers, they can have conflicting visions of what the API should look like, and then it's going to be harder for the producer to satisfy all of them. And there are also sort of the consumer-driven contract approach, which is where the contracts are in the producer, right? But the consumers actually are who evolve the contract, right? So the producer by itself very rarely changes what the contract looks like, but they react in response to the customer needs and what the consumer comes and says, oh, look, I need a new field added, or I need that interaction to be encoded differently. And it's a convenient way to work with multiple consumers while having no incompatibilities between visions for how the API should act. And it also follows very nicely the normal software development process where multiple parties just work together on a single repository. And how it works when you need to evolve a thing. So the consumer works locally on the contract in the producer, and then it sends the contract changes back to the producer. The producer reviews that. They figure out the details, what is the next version of the contract. The producer then runs the build on itself, right? Because we started with the producer side of the things, right? Where we had the build tool and the contracts, and that was defining the things. It will, of course, fail because the new functionality is not implemented yet. And never trust a test that you haven't seen failing. This is a good rule of thumb. I run some tests here. They didn't fail, but I could make them fail. I accidentally debugged a failure yesterday for half an hour because I commented out the error sending, and then I was like, why my tests fail? And then, yeah, that wasn't fun. Right, so the producer evolves, adds the endpoints, changes the code, runs the PRs, the branch is passing, so now we have the stubs automatically generated. They go back to the consumer, and the consumer can run integration tests. And of course, if you need to evolve your both parties in the compatible way, you can always run more tests. Running more tests is almost universally an answer to software development things, right? You can run tests against the new versions of the contracts and the versions of the contracts that are currently in production, right? And verify that both work, and then you can deploy and know that you will not break the past clients and the current next clients. It's very, very easy to do so, again, on your build tool by just utilizing profiles or specifying different jobs in your CI pipeline. And it will work. And because you use this very flexible setup, it will be also reproducible to run on your local machine, which actually will make you not try to be very sad when you have to work with this. Right, and then you can evolve the system in the normal way, sort of similar to how you do database evolution, right? You don't drop the data out of the blue, but you change things incrementally, and then you remove deprecated other things. Right, so this is that. What drives productivity? I think tests are very good. I would love to talk to you about this, but maybe in another session or just somewhere online. And if you want to learn more, testcontainers.com for all questions. Test containers, Olga's repository for the coffee application is there, and the docs for Spring Cloud contract are also available online. Thank you so much for coming. I hope you have a wonderful, wonderful 2 days of the conference. And if you have questions, I'm going to pack my things very slowly, but I'm out of time. Ooh, and also, we were a small startup called Atomic Jar, and we had small stickers. Now we've got acquired by Docker, and now we have the large test container stickers if you want some. They're limited edition. It was a mistake. We are not going to reprint them. So if you want a unique swag, come grab them. And if you have more questions about test containers, there is a booth at the expo. We welcome you to talk to us about anything. Thank you so much.